We're going to have to watch this one slowly appear on the screen. It's the only way we're going to be able to determine it's a galaxy or not. This is NGC7427. And I'm going to look up the data, but I'll tell you, this was an astonishing galaxy. 7427. And if you have a scope of at least maybe 18 inches in aperture at the eyepiece, you should be able to turn this galaxy up. And the reason you turn it up is not necessarily for the views. It's only magnitude 15.4. Its face on 0.8 by 0.8 arc minutes. It's a spiral oblate. NGC7427. It's about 8.5 degrees northern declination, and we went back to the west a little bit to 225709. So 225709 right ascension, declination 8 degrees 30 minutes and 20 seconds. And the reason you may want to know that is this is actually a galaxy. It's not a quasar, it's a galaxy. It is the most distant galaxy I have come across yet. The galaxy is known as NGC 7427, and it is 1.205 billion light years away. And the way they determine that is basically on the red shift. So as galaxies get further away, and this is what prompted the idea of the Big Bang to begin with, they seem to accelerate away from our own Earth and galaxy at a higher and higher rate, which causes the waveforms of light that are emitted by them to get longer and longer. Now, the reason they can tell that they're actually literally getting longer and longer is because there are certain dark absorption and bright emission regions in any spectrum that line up with certain kinds of atomic structures, particularly hydrogen. Ionized hydrogen, for instance. And they know what the pattern is of the spectrum using a spectroscope, and they can see whether that emission or absorption line has moved towards the blue or towards the red, and by how much they move towards the blue or the red. And if they move towards the red a long way, the galaxy starts to get very faint in telescopes, and at the same time it is believed to be moving away at a higher and higher rate of speed. So by determining how much shift and having mapped it out using what is called the Hubble constant, they can determine roughly, reasonable accuracy, how far away a given galaxy is in space. Now, if I had to guess which of these faint fuzzies on the screen was our galaxy, I would say it's that one right there. And what I'm going to do next is I am going to go to full exposure on this to see what it looks like, instead of using these 22-inch scope settings, using the 36-inch scope settings. You'll notice I just increased the shutter speed to 256 flood and the AGC max to 42. That basically is like a 26-inch telescope reach. And you can see now that that galaxy is beginning to show some kind of a halo around it. I've also noticed there's something faint right next to this star here. Now I'm going to go one more step, and that's going to be slightly bump up the decibels. Now it takes 8 decibels to increase the range of a telescope by about 0.8 magnitudes. We're only going to bump up 2 1/4, so that means we're only going to add maybe 0.3 to 0.5 magnitudes in terms of reach. But I do want to use the maximum setting possible, 44.8, and we will give it a second or two. So this is as far as I can possibly go with a 6-inch telescope using the maximum revolution 2 imager settings of sensitivity and exposure time. with 6 stacks of the image. And this gives us a view of a 15.4 magnitude galaxy, 0.8 by 0.8 arc minutes in size, lenticular spiral, located some 1.2 billion light years in space. Now you'll notice from the beginning I mentioned something about quasars. Quasars have incredibly intense, brilliant cores, probably because they have black holes in them that are really, really converting a lot of matter into radiation at their event horizons and their magnetic fields. So, but they can be seen 2 to 3 billion light years distant, even in a small telescope. But this is a true galaxy, and I have a tremendous respect for the fact that we can see it some 1.2 billion light years distant. So let's watch it. Now we're dropping back down to standard shutter and gain settings of 42 decibels and 128 flood. And now you're going to watch that the galaxy is become a little fainter. It looks more star-like. We're only seeing the core. I'm not noticing nearly as much nebulosity around it. So let's bid you adieu for the time being to NGC7427, Galaxy in Pegasus, magnitude 15.4, 0.8 by 0.8 arc minutes, spiral of the lenticular class O, 1.2 billion light years distant. Adios, my friend.